आपला नोव्हेंबर महिन्याचा कार्यक्रम चालू करूया. मराठी मंडळाच्या सिनियर्स फोरम जो आहे त्याचा हा नोव्हेंबर महिन्याचा कार्यक्रम आहे. आता आपल्या आजच्या मुख्य कार्यक्रमाकडे वळूया. आपल्या आयुष्यामध्ये असे अनेक विषय असतात की ज्याबद्दल आपल्याला बोलायला आवडत नाही. म्हणजे दृष्टी आड सृष्टी आपण जसं म्हणतो, ते दृष्टीचे आड जे काय चाललेलं आहे त्याबद्दल काही लोकांना म्हणजे कुतूहल असतं, पण जास्ती त्याबद्दल माहिती करून घ्यायची फारशी इच्छा नसते. तर अशाच एक विषयावर हा जो पाण्याचा प्रवास आहे वर्तुळाकार, म्हणजे पाणी कुठल्याही साठ्यामधून आपल्या घरामध्ये येतं आणि घरामधून वापरलेलं पाणी परत त्या पाण्याच्या साठ्याकडे जातो. हा जो त्याचा पाण्याचा वर्तुळाकार प्रवास असतो तो कसा असतो, किंवा आजच्या युगामध्ये सर्वांच्या खाली खुशाली नीट ठेवण्यासाठी हा प्रवास चांगल्या रीतीने होण्यासाठी काय करावं लागतं, तर या संदर्भाची माहिती, या विषयाबद्दलची माहिती आजचे आपले वक्ते अतुल मराठे हे देणार आहेत. तर अतुलची मी थोडक्यात ओळख करून देतो. Atul is a professional engineer registered in the province of Ontario since 2004. He is working in the field of water and wastewater treatment service since 2003. Since 2015, he is working as a senior engineer at Ashbridges Bay Treatment Plant in the city of Toronto. Ashbridges Bay Treatment Plant is one of the largest wastewater treatment plant in North America. He looks after operations and various capital upgrades for the facility. Prior to joining the city, he has worked with various consulting companies such as EarthTech, AECA, MacViro Engineering, providing services in water and wastewater treatment, primarily in design and construction of greenfield facilities and upgrades. Prior to working in the field of water and wastewater, he worked in India for various companies such as Bombay Dyeing, Garware Chemicals, and Reliance Industries for their petrochemical plants and oil refineries since his graduation in 1992. So Atul, so we are looking forward to your presentation, and the stage is yours.
Thank you, Kaka, and thanks everyone for giving me an opportunity to speak about something. As Kaka rightly said, we don't want to even use those words. Is basically pee, poo, and shit. You know, like we don't want to even use those words. So as Kaka rightly said, it's out of sight, out of mind. The lesser we know about it, the better we are. And that's the topic which is close to my heart, and that's what I'm going to talk about. So please feel free to chime in. Please feel free to interrupt me. तुम्हाला कुठेही थांबवा असं वाटलं की हा याच्या पुढे हे मला नाही समजलं, परत समजाव. So feel free to ask me questions. So I mean, first of all, like आपण कॅनडा सारख्या देशांमध्ये राहतो, तर सगळ्यात महत्वाचं म्हणजे like there is so much of an abundance of water in this country that we take kind of for everything for granted. You know, म्हणजे मला कोणीतरी विचारलं की सगळ्यात पहिल्यांदा तुला या देशात आल्यानंतर काय, like where you felt like you are awed by it. So I said, particularly coming from small village नेवासा, की जिथे पाण्याचं परमनंट दुर्भिक्ष अजून पण आहे, तिथपासून तर पाणी उघडलं की hot water and cold water you get in the tap itself is like it's an awe moment for me. म्हणजे आपण विचार नाही करत या गोष्टीचा, पण that's the real fact. And like म्हणून that's pretty close to my heart. And so from that point, I'm going to start my presentation. So as I said, just stop me wherever you want to, and I'll cycle back and we can continue from that point. Okay. So as Kaka said, like, it's a journey of water from lake to lake. So lake from, the reason I just chose the word lake, because we live in a city of Toronto where we get treated water, or we call it as a drinking water or potable water, or the same words, from Lake Ontario, and we send it back, the treated wastewater back to lake again. So that's the reason it's a journey of taking water from Mother Nature, that is lake, and sending it back to Mother Nature, which is lake again. That's the reason for this title. So what is the water scene in Toronto? That's where I'm going to start with. So Toronto, as I said, as we are blessed with abundant of water, like sweet water particularly. So this is a typical water cycle which all of us have seen, rather have seen it or studied it. Like basically it's a source of water which evaporates, it forms a cloud, the clouds get cooled, and then the water starts, and the cycle continues. That's what we kept on studying it all through the cycle. And then the human intervention came in, and that human intervention was basically purifying the water and then using it. So you basically purify the water, you remove the pathogens from the water, you drink it, and then basically the water, whatever you have consumed, it gets converted, or you excrete it, and then it becomes wastewater. And that journey of wastewater continues, that because the wastewater gets treated, and that goes back to the lake again. So as we live in city of Toronto, what is the water scene? Is city of Toronto is blessed with an abundant supply of like sweet water reserve, which is Lake Ontario. And all the water treatment plants in the city of Toronto are along the lake lines. So the first is RC Harris, which is at Victoria Park and Queen Street. The second one is at RL Clark, which is on the west end of Toronto. The third one is Island Filtration. The fourth one is at Horgan. And the combined capacity or treatment capacity of all this water treatment is around 2,800 million liters a day. So the plants do not produce that amount of water each day, but they are rated to produce that amount of water each day by the ministry. Because water treatment as a matter of fact, in Canada is regulated. So there is a ministry intervention, and a ministry basically issues you a certificate of approval, or it's also called as environmental compliance approval. That is called ECA, to produce certain quantity of water of certain standard. So now the water which is coming, what is the typical process of water? It takes the water from the lake, then you screen it, and then what is water? Water is basically, it's an amalgamation of many ions. So you add some chemical to it, such as alum, which goes through a process of coagulation and flocculation. And then what happens when the ions, you're basically destabilizing them. So destabilization led to basically mingling or coalescing of all those particles to form bigger chunks, and those bigger chunks settle down, and that's what is process of settling. Then it goes to a process of filtration, and the filtered water is disinfected because it still has certain pathogens such as E. coli, and then it comes to us through the trunk sewer schema, various different lines. So in the picture, if you could see, that is one of the biggest water treatment plant in Canada, that is RC Harris treatment plant, which is again on the east end of Toronto. The next one, what is the typical wastewater treatment? Wastewater comparatively is smaller process. So the picture what you see here is one of the wastewater facility on the east end of Toronto that is called as Highland Creek Wastewater Treatment Plant. So the process is basically raw sewage pumping. So all the raw sewage, whatever comes from our toilets, it goes through a series or a network of pipelines to something called as a pumping station. आणि त्या pumping station then it goes through again a process of screening, which removes the bigger material. So what kind of bigger materials? I have seen bigger materials such as 2x4s or pieces of tires, or the worst one I have seen so far is somebody dropping in a filing cabinet. That is the worst I have seen it so far. Then I have seen the bills coming into the wastewater facility. Then somebody losing a wallet coming into the wastewater facility. So these are the stuff. So that is called as a preliminary treatment. Now, then it enters the primary treatment. So what happens in primary treatment? So it contains now pee, your poo, and lot of water. So all the poo particularly, that's we called as solids. So the solids come in along with all the other stuff, and the solids basically settle down. That is called as a sludge. And that sludge is pumped out to a process called as digester. What is a digester? Is nothing but a monster stomach. And then the water, which is passing over from the primaries, it goes to something called as a secondary treatment process, where bacteria eat out whatever the organics which are remaining in water before it sending it out, very clear product to the lake. So this is a typical process. Now, the discharge of effluent from secondary treatment, it straight goes out to the lake, which is Lake Ontario. So there are, again, 4 wastewater treatment plants in the city of Toronto. One is the Ashbridges Bay treatment plant, which is at Leslie and Lakeshore. That is one of the largest. Then second one is Highland Creek. The third is Humber treatment plant, which is on the west end of Toronto. Again, many of you must have traveled via Gardiner, on the Gardiner, right after at around Queensway area. When you pass on the right side, you would see some a big green building. And that's what is a wastewater treatment plant. That is a Humber treatment facility. And the fourth one, which is North Toronto wastewater treatment plant, which is in the O'Connor Drive area, within the ravines of Don Valley Parkway. Wherever you see coming on Don Valley Parkway on the right side, many of you must have seen a big elephant on the right side. So it's right within that area, there is a wastewater facility, and that is called as North Toronto treatment plant. So combined all this treatment, wastewater treatment, it treats around 1,544 million liters per day of wastewater. So how much do we treat? So Ashbridges Bay treatment plant, there is a sewer shed of around 25,000 hectares. It serves to a population of around 1.5 million residents. And the rated capacity of the plant is 818 megaliters. And the hydraulic capacity is 3,300 megaliters per day. Now, all these numbers are big numbers, but how does it relate to you and me for me to understand how big those slides? So as I said, is each bathtub in our house, it holds around 200 liters. Okay, so the treatment plant all combined, it holds around 5.2 million bathtubs, just to give you the gravity of it. Now, the other one is, it is also equivalent to 325 Olympic-sized swimming pools. That's the kind of a treatment what we are talking about. But do we treat that amount of wastewater each day, that quantity? Absolutely not. but sometimes we get inundated with water, particularly the rainwater or the melt. So, and that's what we call it as hydraulic capacity. So Ashbridges Bay treatment plant is rated for a maximum hydraulic capacity of 3,300 megaliters, which is 3,300 times 1,000 liters per day. So the picture what you see on the left side is the screening building. That's where all the wastewater first comes in, which whatever is pumped, and then it gets screened to go on to the next treatment processes. So basically, at Ashbridges Bay has multiple raw sewage pumping stations, which I'm going to cover next. So let's talk about it. So as Kaka rightly very started, this is the typical toilet what we see, and no one wants to talk beyond this point that, yeah, it's kind of out of sight, out of mind. So in just bit history about the wastewater treatment now. So these are the Romans, we call them latrines. अजून पण भारतामध्ये खूप लोक it's a latrine, but so it's a Latin word. And what used to happen with the sewage? They used to go to the streams and the rivers. And unfortunately, this situation is still the same in many developing countries, including India. So flush the toilet, basically, it became a popular terminology in late 1800s. So these are some fun facts, nothing more than that. So these are the early Toronto sewers. So on the right side, it's a midway sewer. What is a sewer? Is nothing but a circular structure which is lined by bricks through which the wastewater carries. Now, what is the size of a sewer? So the size of the sewer, it varies within the city of Toronto from 15 centimeters, which is 150 millimeter or 6 inches, to all the way up to 300 centimeters, which is the 3 meters, which is the Mid-Toronto Interceptor, which takes the wastewater from all the downtown core, bringing it out to the wastewater facility at Ashbridges Bay Treatment Plant. Any questions up to this? So these are the earlier sewers, which are the Garrison Creek sewer. And as we said, like, this is the topic no one wants to talk about. There used to be a lot of corruption and incompetence in earlier times, but over time, situation has drastically changed. So this is an earlier picture of the Sunnyside Beach, where you could see on the left side of the picture that where this one of the kid is sitting is nothing but a monster heap of wastewater sludge reaching over there. This is very early pictures. And then, so when Toronto started developing, we said, like, basically the politicians in city of Toronto started talking about what is a better scene to treat the wastewater. So we were looking at London's interceptor system. City of London already had the interceptor system by then. So what we thought, okay, let's copy London. So how does an interceptor system work? Now there are two kinds of interceptor systems. So the first is, assume it's a circular pipe, and the circular pipe is bifurcated into two parts. So there is a mid wall, and on the one side, that's where the sanitary comes in. That's where our toilet flush comes in. Whereas on the other side is where the storm water comes in. So city of Toronto, particularly जी olden city आहे, जो जुना भाग आहे, तर त्याच्यामध्ये they call it as a combined sewer. So that's what the combined sewer term came in. So combined sewer मध्ये the storm water comes in on the left side and the sanitary water comes in on the right side. पण जेव्हा पाऊस पडतो तेव्हा the storm water, it gets inundated and it spills over onto the right side, which is the sanitary side, reaching the treatment plants such as Ashbridges Bay. Now that is called as a combined sewer. Now the newer city, it completely has two parts now. There are two separate lines. They carry stormwater separately and the sanitary water separately. So that is basically, we all call them as interceptors. So as I said, let's copy London. And then we started building in 1910 was the first time when we started thinking about it. And very soon we had our first wastewater facility in the city of Toronto, which started the construction in 1913. So this is the mid picture is the first wastewater treatment plant which came in operation in city of Toronto in 1913. Its construction started, but the wastewater really started processing it in around 1917, 1918. And this plant is still in operation. This is on Eastern and Coxwell. So anyone who is interested, if you travel on Coxwell Avenue, which is from Lakeshore and Coxwell, on the left side, you would see this building, which is we call them as M&T building, which has been converted into merely a pumping station. But on the right side of this facility, there is a wastewater treatment facility, which is kind of, it's all covered areas. And you would see, if you go tomorrow or today, you would see basketball field on top of it, right? But that's the that is the first wastewater treatment plant what we had, which is now merely a pumping station. So and that's where the Ashbridges Bay treatment plant, it started. So it started expanding from 1913 to this day. So this is the 100 years evolution of Ashbridges Bay. So in 1910 to 1913, the design of that first facility started, and since then it is in construction. So to this day, the capacity of the original treatment plant was merely 150 million liters, and now over time it has been expanded to 818 megaliters, which I said, like 818 times 1,000 liters per day. So we, on a given day, we normally treat around 600 megaliters on a given day. As on today, when we had around 7 to 8 millimeters of rain, currently the flow of the plant, which is processing it right now, is around 1,000 megaliters as on today. So these are the various developmental phases of the facility. So during 1960s and 1970s, as the city grew, we started our secondary treatment system. Then we started incineration, and early 2000 we stopped incineration, and 2010 and future is basically there will be a capital spending of close to $2 billion to improve our wastewater. So this is the typical sewer shade of the treatment facility. So the continuous improvement and expansion led to the current capacity of 818 megaliters, which is approximately 320 Olympic size pools. On the right side, where I'm moving my mouse right now, it's kind of a greener area. That's where Highland Creek wastewater treatment plant is. And that's where I'm circling right now. That's a Highland Creek wastewater treatment plant. It takes care of most of the wastewater from the Chemical Alley and Scarborough region. Then the lighter green, like on the north side, all the way up to Steeles, and on the left side, on the western side, in approximately around Bathurst area, and on the right side, approximately around Victoria Park area, that is taken care by Ashbridges Bay treatment plant. So within that, you would see a gray area. That's what has been taken care by North Toronto treatment facility. Now, on the left-hand regions or on the west side, there is another wastewater facility, and that is a Humber treatment plant, which is again just near the lake. That is the Humber treatment. So this is complete sewer shade of wastewater scene in Toronto. So along the way, does all water come by gravity? Absolutely not. So there are approximately 84 pumping stations within on strategic locations, which basically pump out the wastewater to pump it out to the sanitary sewer. So basically all these treatment plants, they treat wastewater from industrial, commercial, and residential sources through a complex system that is made up of around 6,000 kilometers of pipe, ranging in size from 15 centimeters, which is 6 inches, to all the way 300 centimeters, which is 3 meters. That is the largest size of an interceptor in diameter. If these pipes are stretched out, they would reach across Canada from Cape Spear in Newfoundland to St. Elias in Yukon. So the system is very complex. There are like around 84, as I said, 84 pumping stations, which basically pump out the wastewater from the valleys, from the low-lying areas, and pump it out to the sanitary sewers. And that's what carries the wastewater all the way to treatment plants such as Ashbridges Bay or Highland Creek or Humber or North Toronto treatment facility. So this is the deepest, which is around empty. We call that as a mid-Toronto interceptor, which was in construction in 60s, which is still in operation. It is 16 kilometers long, and it carries around 1,500 megaliters, and it is 25 meters below ground. So the sewer shed, as I said in the previous photograph of the North Toronto. Now, the oldest water treatment, wastewater treatment facility in the city, as I said, like it was constructed in 1913, and that we call it as an M building. Some people might ask me out of like, why do you call that as M building? I really don't have a clue why we call that as M building. But the buildings in Ashbridges Bay are like, instead of by the names, they are, it's called as, one is called as M building. Maybe the only reason I can think of is because that is called as main treatment facility, and that's the reason M came in. But the below the M building is called as T building. This is a circular structure. Again, you would see on Coxwell and Eastern Avenue. If you Google out, right, like whenever in your spare time, you would see amazing pictures taken in the night times of this site, which is T building. And the third picture is a Coxwell sanitary trunk sewer, which starts at O'Connor Drive, bringing in the wastewater from the sewer shed all the way to the Ashbridges Bay. So this is a facility which is a pumping station, which is a raw sewage pumping station, that is M&T building, we call it as, fondly call it as, brings in the water from Coxwell sanitary trunk sewer. And then there are additional tunnels which bring in the water. One is on the Eastern Beaches Tunnel, which brings in the water on the eastern side of Lakeshore. Then Ashbridges Bay has two preliminary treatment trains. One is called as D building and one is called as P building. Again, no reason why it is D or why it is P, just these are the names. Then it has a common secondary treatment facility. So the M and the D and the P building, which are the preliminary treatment facilities, are located here. So where my mouse is moving right now, that's where the P building is. And on the left side, where my next mouse is going, that is the D building. Towards the end, I'm going to show you a bird's. I have some drone photography to give you the mammoth scale of the facility. So this is a secondary treatment plant, which basically takes the whatever comes from the P and the D building, it comes to the secondary treatment facility where bacteria consume it before sending it out to the lake. And these are the final tanks. And underneath the final tanks, there are conduits which are taking the treated water back to the lake. So the circular structures, what you see where I'm moving my mouse right now, these are called as digesters, which are nothing but monster stomachs. So what does wastewater contain? It contains suspended solids or the solids. Then the organics which carry, there is organic load or BOD. Then there is ammonia, which is by virtue of our P. Then there is phosphorus, and there are dissolved ions, the salt what we eat. One of the funniest funniest thing what we have noticed it, you could see in wastewater treatment plant on screenings the impact of corn on our lives. Like some of the picture, I mean, I don't have the pictures over here, but on the screens, when some games are happening, you could see like how the cons come in because people are going to the bars. You would see increase in capacity or increase in flow when there are games going on. You could see these kind of patterns in the wastewater facility. Same thing, that's one of the reasons many of you must have seen it. When COVID started, they started sampling wastewater. That gives you early signs where the next outbreak of COVID could be coming in. So the process, as I said, it's divided into two parts. One is the liquid stream, whereas all the liquids come in, and the second stream is called as a solid stream. So solid stream is a red rectangle, and the liquid stream is a blue rectangle. So what happens in the liquid stream is the wastewater comes in, it gets screened, then you basically primarily treat it. Then it goes under the secondary treatment process. Then it gets disinfected. Basically, you are killing the pathogens by virtue of using chlorine. That is, we use sodium hypochlorite. Earlier, we used to use chlorine gas, but now we use sodium hypochlorite. And then that's the disinfection process before we send it back to the lake, which is deep in lake, around 800 meters offshore, the water is discharged into the lake. Now, what happens to the solids? The solids are pumped back to something called as digesters. And the process of digestion, it produces the biogas, or that we also call it as a digester gas. So that digester gas is used to heat the water, which is being used for hot water applications or in the buildings to keep the buildings warmer. So we self-consume all the digester gas, particularly in the winter season. In the summer season, unfortunately, we'll have to take the natural gas from the Enbridge to keep the things running. Then the solid concentration in digester is around 2%. There is still a lot amount of water in it. So we send it through a process, something called centrifuges, where it gets concentrated to up to 28% solids. And then the 28% solids are basically converted into pellets. That is for a beneficial use, and which is being used as for fertilizer purposes. So that is the solid sides of treatment, and the top is the liquid side of a treatment. So this is the 1913 facility, which is nothing but M building pumping station. The red one is the first plant that was built in 1913. The bottom one was an extension or expansion completed in 1947-48. And around 1947-48, the council started thinking about that, okay, the population of city is growing, and now we have to think about where the upgrades would be. The upgrades came on the other side of the lake shore, which is on the south side of the lake shore. So in 60s, the Mid-Toronto Interceptor, which is the 25-meter deep, but 3 meters in diameter, trunk sewer was built in, which takes the wastewater and brings it to the Ashbridges Bay treatment plant. So the capacity of Mid-Toronto Interceptor is around 1500 megaliters. It is coupled, it is basically the wastewater is pumped by virtue of 5 monster pumps, Each pump is rated for 1400 horsepower motors. So these are some of the pictures of the T building, which is 65-meter deep building, again on the intersection of Lakeshore and Coxwell. Northwest corner, you could see these both the buildings. It's pretty deep, around 65 meters deep, and on the left side, this is one of the pump, which is the motor of a pump. And this project was done by Jacobs or CH2ML in 70s. So the liquid stream, so the preliminary treatment or the screening, what is the purpose? Basically remove the rags and the floatables, 2x4s, tires, everything gets removed from the primary treatment. It is nothing but a screening process. There are 6mm holes on the screens, and the water goes through it, but all the solids, they get deposited. So on the picture on the left side, these are the typical screen panels, and you could see the corn kernels on it. So this basically tells you the impact of corn on our lives. It's being used as an additive in almost everything. Then again, the wastewater also contains a lot of sand, because with the construction of, people used to sometimes dump sand into, or wherever when the rain starts, it takes away all the soil along with the sand. It goes to the sanitary sewer, and that it ends up here. So these are basically inorganics. There is no inorganics, means these are additives which get added to our water, to our wastewater, and you need to remove them. So we call them as a grit, and those grits are removed as a part of the preliminary treatment processes. Then right over here, you add a chemical called as a ferrous chloride, which is an acid, and you try to control phosphorus here, because ministry, it governs you what is the level of phosphorus, what you expect before you send it back as an effluent product back to the lake. So the organic solids are the poo again, basically, along with whatever the dissolved portion of a poo which is in the water, it's settled out in the preliminary treatment process or a primary treatment process, which is pumped to the digesters. So this is a typical primary tank, which is approximately 96 meters in length and 36 meters in width and around 6 meters deep. So we have around 18 tanks, 6 plus, around 12 tanks of these sizes. So whatever the water which is from the primary effluent, now the solids have been removed, which will be taken over to the digesters. But what happens to the water, it still carries a lot amount of dissolved organics, and those dissolved organics are eaten away by the bacteria. There are multiple bacteria based on the temperature which are in the tank. You add water to it because this is an aerobic process, and these are the diffusers which are in each of the tanks. We have 11 of these tanks at Ashbridges Bay Treatment Plant. So these are all covered tanks. When I'm moving my mouse, these are all the covered tanks. And so bacteria eat away all the organics, and whatever water which remains, which is much, much cleaner water, it is sent out to the conduits for further disinfection process. So the aeration system consists of aeration clarifiers. Each tank is rated for around 91,000 cubic meters per day. And the flow of then whatever the solids which have been eaten away by bacteria are taken to the digesters for further treatment. So on the beaker, you could see the impact, how the treatment is occurring here. So on the left, the leftmost beaker, what you see is all the wastewater plus the settled portion at the bottom, that those are the solids, and the top one is the liquid, which is out of the primaries. And as it goes through the processes, it gets cleaner and cleaner. So these are the blowers, and which is basically adding air into the aeration tanks. So secondary treatment, washout and bypasses. I'm sure this is one of the topic which is near and dear to a lot of people. So yeah, occasionally we have bypasses, particularly when we get inundated with a lot of water or the rain. So as I said, the plant is rated for certain capacity. So what do you do with the wastewater or the water which is still coming in to the plant? Unfortunately, you have to bypass it. So it is treated with chlorine, it is disinfected, and then it is sent back to the lake. So City of Toronto has something called it as a flag program. So people who go to lake quite often, they must have seen it. The colors of the flags do change. So as the color changes, it is basically a sign that, okay, the color is red now, so you basically don't go in lake and swim. But the color is green, then you can go and take a dip in the lake, because that is a flag program, and it gets affected by the bypasses which are occurring in the wastewater facilities. But the bypass is always a treated bypass. So the wastewater which is coming out of the secondaries, now it still has bacteria, which is basically an E. coli, which can cause dysentery. And you kill those pathogens by virtue of adding sodium hypochlorite to it and maintaining certain contact time. So the solid stream it consists of the digesters, then the dewatering facility or the centrifuges, and the pelletizers. So the retention time in each of the digester is around 15 days. All the solids which have come into the plant are retained for 15 days. So they are stabilized. The biogas is produced from it, which is used in the plant itself. And the solids which are settled in, these are around 2.5% solids in it, which is further concentrated to 28% for further disposal. So these are the centrifuges. The output of the centrifuges is around 28%. And what is WAS is waste activated sludge. These are all the industry jargons, So the biosolids which are produced in the wastewater are to 28% solids now. So you convert those 28% solids into pellets, and those pellets are used as a fertilizer. So the pellets are dried to around 94% solids, and then many of you must have seen it as a Nutri-Pill label sometimes in Canadian Tire, and that's what the pellets which is being from this is an organic pellet which is from Ashbridges Bay most of the times as a Nutri-Pill. And it's a facility which is currently operated by a French company called Veolia. So this is a typical process. So we treat around 150,000 wet tons of biosolids annually, and out of which is around 84,000 wet tons are converted into pellets by Veolia, whereas City sells the remaining 70,000 tons of wet tons to different farmers. There are commercial farming which happens in the London area or in the Kingston area. They take a lot of biosolids from us. Everything goes for beneficial use, for agricultural or processed into a fertilizer, or for soil conditioning product. None of it is sent to landfill. So like this is an interesting slide. I always love this slide. On the left side, these are the influent. This is the wastewater which is coming in to the plant. It has suspended solids around 280 milligrams per liter. And the effluent, which goes back to the lake, is around 5.4 milligrams. So the reduction in solids is 98%. Solids have already been removed. The biological oxygen demand, or which are the organics loading, is around 202 milligrams per liter. What goes out as an effluent from the plant is 4.1 milligrams per liter, whereas TP, which is the total phosphorus, is 6.4 milligrams per liter, and what goes out is 0.7 milligrams per liter. So last in 2018, we had around 2017, we had around 7 bypass events, totaling around 1,570 megaliters. And as you know, 2017 was a year when we had lot of rain, where the lake water went up. So how the lake level is connected to the wastewater facility is we have combined sewers. At combined sewers, there are strategic locations. Combined sewers have overflows, and those overflow go back straight to the lake. So when the lake level went up, the lake started coming into the collection system. And as Ashbridges Bay, we started treating lake water again. So this is an impact of global warming. Either you believe it or not, it's on us. So 2017 was the first year, for the first time, we ever experienced the rise in the lake level. And 2019 was another year when we experienced the rise in lake level again. So this is a typical team what we have. Like Lou is our general manager for the Toronto Water. He looks after the water and wastewater both. And these are the directors. So Frank is my director, and William Fernandez is the director for the water side. So this is the Ashbridges Bay typical structure, that we have a senior manager by Scott looking after the capital and Colin looking after the engineering services. There is a continuous staff of around 170 people which work at Ashbridges Bay. Now the water, or the effluent water which is created, which is tested more than 5,000 times a day each year to ensure that it is safe to discharge to the lake. The annual operating budget is around $57 million. So what happens now? Everyone would ask me, okay, what happens with the stormwater? As all of us, and many of you must have noticed it, is over time, there is more and more urbanization of City of Toronto. The area where there used to be soil, now it is covered with concrete. There used to be roads, the roads are now paved. So what happens when the urbanization is happening? So earlier, when there is a rainwater, rain would have an opportunity to get absorbed in soil below. But now it's not happening. It's running off. It's running off to the wastewater facility, and along which it carries all the solids, all the leaves, or whatever is on the way, it carries out to the like treatment facilities such as Ashbridges Bay. This is basically a stormwater carrying all the solids. Now, combination of heavy rains and hard surfaces and more water reaches to the plant. Earlier, that never used to happen. So what can I expect from you? And this is what is: do not push, flush, or put any of these products down the drain. Even many of the times you buy a lot of products which are basically written as flushables, but those are not flushables. Like the baby wipes is an interesting example. If you go to like Costco and you buy baby wipes and you say, yeah, you can flush it. No, you cannot, because they basically blind the screens. Hygiene products, condoms, wipes should not be put into the toilets. Fats, oils, and cooking grease. I mean, this is not a problem particularly for the household, but there are so many restaurants which put a lot of cooking grease back into the site, which binds or blinds the treatment system. Then the household hazardous waste, including paint, pesticides, and cleaning products, should not be put into the wastewater or flushed down the toilets. Same thing, medication, including pills and liquids. There are completely separate facilities which do take these kind of hazardous material. And if you go to Toronto's website, you would find it out that who takes the household hazardous waste and paint. For an example, people living in the downtown core on Eastern on near Ashbridges Bay treatment plant, there is a waste hazard depot. You can just dump in whatever paint you have, and they're not going to charge you a dime. Same thing in O'Connor Drive, there is a waste hazard depot, something called as a Bermondsey area. They will take your product, they'll not charge you anything. So now I'm going to talk about the future of wastewater, where the close to $2 billion will be gone, will be for treatment of basically the water quality. The next future is towards the treatment of water, which is the storm water. And that's what I'm going to, like, basically I might have to stop sharing the screen because somehow Zoom doesn't allow it for me to create it. I'm going to open it a different window and then I'm going to share it back again. Just bear with me. So this is the future of wastewater treatment, or where the $2 billion would be going. There will be a lot of projects in treating the storm water. This is a photo of a tunnel boring machine, which is creating an underground infrastructure where the wastewater, the storm water, would be stored and then slowly discharged for treatment. This kind of a system is extensively used in Europe. So these are the underground tunnels which City of Toronto is building up right now. The other facility which we are doing it is integrated pumping station. So M&T building in the earlier times, which I have shown, those are at the end of their life. So a new integrated pumping station will be built, and this is the integrated. So if you go again into the same area, which I would suggest you to drive by, there is an artwork. So the local artists who live in the area, they were given an opportunity to present their art on the structures of the wastewater facility. So this is the artwork of the local people, and this is the integrated pumping station, which is in construction right now. So this is the M&T building. So the circular building is a T building, and the rectangular building, which is the 1913 facility, which is M building. So this is the construction at Ashbridges Bay facility. This is around 65 meters deep shaft, which is being in construction right now. The other project, which is land farm, so basically reclaiming the land from the lake. So the facility is here, and this is all the reclaimed land from the lake. So whatever the tills or whatever the excavated soil from the shafts within the City of Toronto has been dumped over here to create the facility for the next high rate treatment facility, which is going to treat the storm water. Then over time, we are going to stop the use of sodium hypochlorite or chemicals for treatment, and the effluent water coming out of secondaries would be disinfected with UV, that is ultraviolet light. So this is a construction of those facilities. So this is where our tax dollars are going. Now I'm going to again stop sharing the screen, and I will show you a drone footage of the current facility. So this is the current facility. These are the final tanks. These are the digesters. And this is all the reclaimed land from the lake. These are the primary tanks. Some are covered, some are not covered. Now this is the last probably a movie I'm going to show it to you, which is again on the City of Toronto's website. Now, all these big projects haven't been completed by the people who are currently working. Like this is years and years of preparation in place. Many people have worked, retired over time. So what is Marathi Mandir's contribution to it? I'm sorry, I haven't, I'm going to take some names. Sorry, some of the people, they are present here. And so like Madhu Bide is one of them. Many of us know Madhu Kaka, like he is involved into many of these projects. He built the electrical substation at Ashbridge's treatment plant, which is one of the massive one. Same thing is Abhay Tadwalkar, many of you know, may have heard it. He was involved into the development of these projects. So as Vijay Ratna Parkhe, who was involved in the development of bylaws, which are then what needs to be sent back to the treatment system. And there are currently some people who are still working. As a matter of fact, Archana Medekar, the other Archana Medekar, she looks after all the training which has been given to the treatment facility. Then Mukund, who is another guy. These are the Marathi people who were involved into the development of all these facilities. Thank you very much. Any questions?
Yeah, please raise your hand, and if you use that hand gesture that is there in the reactions button, it is always better for me because I can see that very quickly. Okay. And Atul, I will start off by just one comment that I was fortunate enough to visit one of those waste management plant when I worked for the region of PL. And I knew William Fernandez personally because he used to be there. And I used to see many of his presentations. And one time, jokingly, I had said to him that, William, I had never seen anybody talk so passionately about human waste. And he used to laugh. So I just wanted to share. And I also would like to tell people that if you do get a chance to see one of these plants, they are fascinating. We often go on vacations and want to see new things. And these plants are really fascinating. And, it kind of opens your mind that what we live, we don't know what we do because we take things for granted. So this was my comment. And I think I'm looking for the hands Oh,
I think Wakils have raised their
yeah,
hand.
Wakils. Yeah, Dr. Wakil.
Yeah, Atul, excellent presentation. Thank you very much.
I mean, there are opportunities to visit the waste. I mean, I wouldn't, because of like the age group, I would not suggest you to go to the wastewater facility. But for water treatment facilities, there are tours available. Just let me know and I can kind of help arrange. Particularly RC Harris is an amazing water treatment plant you could visit, which is very safe. You could go on one of the Fridays for an hour or so. Wastewater facility, I would not say go and visit in the given age with so many viruses, because when I started working, my first interaction was I had diarrhea on the very first week after joining Ash Bridges Bay, because you basically touch so many places, the doorknobs where these bacteria do reside, and then you sometimes unknowingly you try to put these hands into your mouth or eyes, or these things happen very unknowingly, you know. So I would not take any one of you to wastewater facility, but for water treatment, it's one should go and visit.
Video off आहे what?
Hello, Kaka.
तुझा व्हिडिओ ऑफ आहे. हा that's okay. ओके अतुल, मला एक प्रश्न आहे
हा बोला ना काका.
की मध्ये ऐकलं होतं मी, तू यू मेड अ रेफरन्स टू दॅट की कोविड जे चालू होता,
बरोबर.
अजूनही मोठं हे करत असतील की वेस्ट वॉटर मध्ये दे वर डुईंग सम टेस्टिंग फॉर स्मॉलर रिजन्स.
Correct.
That could give an indication of the prevalence of COVID in certain areas.
बरोबर.
How does that happen? I mean, what are
So,
those areas?
basically, these are the
how small
viruses.
those areas are?
So, Kaka, basically, these are the viruses, right? So these viruses, people do excrete those viruses, right? They come into the wastewater stream, and by taking the sample, you kind of start getting early signs where the next outbreak could be occurring. So they kind of provide you early signs.
Is it reliable and useful?
Yeah, it is.
It is.
I mean, Vardekar Kaka might be able to comment on more about it.
Shalan, you have question? Shalan, go ahead.
Madharav. Very good presentation, Mr. Marathe. There
Thank
are
you.
several questions come to mind. For example, for the city of Toronto, which has, a, if you take it, population of around 3 million or 3 to 5, 4 million, if we include Mississauga, what is the daily average consumption of water on a per capita basis in terms of liters? Like 50 liters,
very good
liters,
question.
150, and how does it compare with other cities in Canada or elsewhere in the world?
Very excellent question, Kaka. I really don't have that kind of a data, but over time, what I have noticed it is, so whenever water treatment facility is designed, the assumed consumption or the baseline data is around 275 liters per day per person.
Oh.
आणि मग त्याला ते prorate करतात, like for designing a treatment facility. But over time, what we have been noticing is, I mean, I have been visiting this site since 2010, but the flow rates are within the same range of 550 to 600 megaliters, but the concentration of solids is increasing. Means earlier there was more dilution, but so the flows have remained constant, even though the population has grown. I mean, when I came in Canada, the population of Toronto was around 1.2 million.
That's
Or
right.
1.5 million. And now it is 2.1 to 2.5 million. But the flow rates have remained very constant. What it tells me is we are consuming less and less water every day. Means,
Interesting.
but the concentration of solids which is coming up has increased.
Oh, okay. One small question.
Sure.
With the present hype about climate change, you did mention about methane and carbon dioxide.
Correct.
Any rough estimates about how much CO2 is generated in all these processes? I know it doesn't do anything to the climate, but just a curiosity.
So
Everybody is talking about reducing CO2.
This is another very good question. If I mean, like, I can talk to you offline after this conversation, Kaka, particularly the CO2 data, but the current plan is yes. So what we are doing is offsetting some of the carbon dioxide, like basically the methane gas or digester gas is to be offsetted because we do produce it. As a owner, we need to take the responsibility of it.
Okay.
आणि म्हणून आता आमचे नवीन प्रोजेक्ट जे चालू आहेत, these are basically to offset the gases which are being produced, you know. So how do we offset it is like by virtue of capital investment into renewable energy sources. So there are projects such as like solar walls are being built at Ashbridges Bay. Then we have a big monster solar farm which is being constructed right now. The next project which is going to come up is in addition to the solar, but the treatment systems, the improvement in the treatment system, such as we consume less and less electricity. You know, so we are trying to offset it, but some of it we will not be able to. Unfortunately, that is the truth.
Okay, very good.
How good is the solar electricity generation? Because Ontario gets lots of cloudy days. So
Yep.
I'm not sure that we really are located in a place where, say, being
Sun is
in
not very strong.
Winnipeg or Manitoba might be better for solar than here in Ontario.
So, you know, Shalante, another very nice question. That project is on a trial phase right now. So maybe in next year or so, we'll have a good data to back it up. Like, but I mean, if we just go by that virtue of and not invest money into it, then we'll never have that kind of availability of data either, right?
Right, right.
Yes,
I mean,
I agree with you. And that's the reason, I mean, even the countries such as India, which has an abundance of solar power, storing the solar power is the biggest problem.
yeah.
Yeah.
Not enough storage capacity is there. Therefore, it has to be consumed almost right away. If it's produced, it's got to be consumed. And that's the equation.
तर आम्ही आता काय करतोय की जो जे वापरणारे जे सोलार ट्रीट जनरेट होणारे, we are going to consume it right in the same building where the solar panels would be. So kind of taking away the need of battery storage.
Right, right. At least take away the load from hydro.
Correct.
Just an observation. We were in Grand Canyon
Uh-huh.
drinking a glass of water, and someone said this was from yesterday's beer. And secondly, the State College, Pennsylvania, is a very
Uh-huh.
small town, and whenever there was a ball game,
Mhm.
everybody went to the ball game. And that's when there was such a draw on water, everybody flushing. So we were developing a product to do some management of services. And that's when we ran into this interesting information that anytime there is a ball game, there's a huge draw on water.
True.
Yeah, draw of water.
Thank you.
Okay, Mr. Vishwanath Kulkarni had question. Yeah, okay, go ahead. Unmute yourself, Vishwanath. Mute वरती आहात तुम्ही, unmute करा. हा,
हा.
आता बोला.
सतीश कुलकर्णी अतुल
Oh, sorry, yeah.
एक मी डॉक्युमेंटरी पाहिली. फ्रान्समध्ये पॅरिस हॅज अल्ट्राव्हायोलेट ट्रीटमेंट फॉर द ड्रिंकिंग वॉटर. आपल्याकडे तसं काय होणार आहे का?
नाही, आपल्याकडे ऑलरेडी आहे. आपण युव्ही ट्रीटमेंट चालू आहे. म्हणजे पोर्टेबल वॉटर साठी ते वापरतातच. बेसिकली इट रिड्युसेस द लोड ऑफ केमिकल्स ऑन टू द स्ट्रीम, यु नो. पण आता वेस्ट वॉटर साठी पण वापरतोय. पण इट्स काइंड ऑफ अ catch-22 टू बी ऑनेस्ट विथ यू. म्हणजे द रिझन आय वुड से catch-22 because UV consumes a lot of electricity.
Oh.
You know, so what is a better evil? Like,
But,
kind of.
but city like Paris, if they have it, म्हणजे आपल्यापेक्षा पॅरिस मोठा आहे, and they have that UV treatment there, and
Yeah.
along with that, they also provide the fountains along the city where you can fill up your water bottles, including carbonated water bottles.
Wow.
Hmm.
Interesting.
Do we have something like that here?
I mean, we have water
Fountains?
fountains. We have water
Fountains?
fountains, but not the carbonated, unfortunately.
Oh, okay.
मीना घाणेकर क्वेश्चन होता का नाही ना? नाही. मग अन्विता, तुझा हात अन्विता शशी जोगळेकर या.
थँक्यू अतुल, वंडरफुल प्रेझेंटेशन. मला कधी सोपा प्रश्न आहे की एवढी मोठी यंत्रणा काही आपल्याला बाहेरच्या दुसऱ्या ग्रहावरती पाठवता येत नाही, तर सध्या आपले जे विमानं जात आहेत आणि इतके दिवस ऑर्बिटमध्ये असतात, तिथे पाणी स्वच्छ करण्यासाठी काय वापरलं जातं?
खरंच नाही, माझा त्या विषयावर नाही अभ्यास, पण आय थिंक बट दे रियूज द वॉटर.
Yeah, but it has to be filtered, it has to be clean.
Correct.
How do they do it?
I mean, I will certainly do a research about it. मला नाही कल्पना त्याची.
Okay.
दुर्गाताई,
माझं मध्ये मी काही वेळ बंद झालं होतं, म्हणून मला जर हा प्रश्न विचारला असेल कोणी तर इट्स ओके. मी विचारते एवढंच की नळाचं पाणी सेफ आहे प्यायला असं अनेक वर्ष ऐकत होते, पण मी गेली काही वर्ष ब्रिटा फिल्टर वापरते. म्हणजे जस्ट पण आपलं लेकचं पाणी किती म्हणजे हे आहे का, म्हणजे ब्रिटा वापरणं बंद केलं तर चालेल?
You know, this is my suggestion. Don't buy bottled water or Brita filters.
Okay.
Don't buy. Just, I mean, मला कल्पना आहे की particularly जेव्हा आपण सिटी ऑफ टोरंटो मध्ये राहतो, तेव्हा some of the pipelines are old. So one of the other way is you want to drink the water, just keep the tap on for a couple of minutes and then take a tap water, which is much more safer than a bottled water what you buy at Costco or any other place.
Or Brita. म्हणजे मी Brita.
I mean, okay, so from Brita, how many times you basically change the carbon?
About every 2 months.
Okay, पण 2 months मध्ये त्याच्यावर बॅक्टेरिया ग्रोथ होत असते, राईट?
हो, असावी. बरोबर.
ते पण आपण पितो, राईट? लाईक ते तर आपण काढत नाही.
ओके, म्हणूनच मला विचारायचं होतं की सरळ नळाचं पाणी सरळ प्यावं झालं.
सरळ नळाचं पाणी प्यावं.
ओके.
And particularly living in Toronto, it's one of the safest water you would ever drink.
Agreed.
पण आता तुझं प्रेझेंटेशन ऐकून सगळं मला सोनखत, आमकं खत वगैरे सगळं ऐकल्यानंतर मी म्हटलं, ओ माय गॉड, आता हेच पाणी ऑन्टारियो लेक मध्ये म्हणजे शुद्ध करून सोडतात, पण मग मनात भीती वाटते की नाही भीती नाही वाटत, म्हणजे तशी नाही वाटत, कारण तू चांगलं एक्सप्लेन केलंस आता. असो, वय झालं आता म्हणायचं आणि सोडून.
असं नाही मावशी.
आणखीन कोणाचे हात मला दिसत नाहीये. सतीश कुलकर्णी अगेन. या
आपलं पाणी किती प्रमाणात क्लोरीन त्याच्यामध्ये असतो?
We maintain around 1 milligrams per liter of chlorine in it, in addition to the other fluorides and other stuff. And the reason we maintain around 1 milligrams per liter, कारण की, so there are two things, right? One is direct chlorine, what you add in, and one something called as a chloramines. So the chloramines is basically पाण्यात जो ammonia असतो, aqueous ammonia, it gets added with chlorine, आणि त्याची जे disinfection power, it lasts for longer time instead of, because chlorine dissipates very quickly.
पण समजा पाणी ओव्हरनाईट ठेवलं तर क्लोरीन
निघून जातं. Yes, पण the chloramines, that's what the chloramines जे असतात, that gives you that disinfection power.
Oh, I see. Okay, thanks.
मध्ये पेपर मध्ये सारखं यायचं की हॅमिल्टन मध्ये काहीतरी 15-16 घरं होती आणि त्यांचं वेस्ट वॉटर त्या लेक मध्ये डंप होत होतं आणि नोबडी न्यू अबाउट इट.
Yeah, that's always unfortunately that was true probably.
ते खूप वर्ष चाललंय म्हणे. So what was that about?
It was probably हॅमिल्टनच्या लोकांना माहिती नव्हतं की कोणत्या तरी सिस्टीमला कनेक्ट केलेलं पाहिजे ते. I would say it's more an accident, right? Like nobody would do it intentionally.
अतुल, एक प्रश्न असा की आपण टोरंटोमध्ये तू आता सांगितलंस की वेस्ट वॉटरचं ट्रीटमेंट कसं होतं, तर याच्या तुलनेनं भारतामध्ये काय होतं?
काका खूप कमी ट्रीटमेंट आहे भारतामध्ये. लाईक आय मीन लाईक याच्यातले पुष्कळ लोकांचं पुण्यात तुम्ही जात असाल तर पुण्यामध्ये फक्त अजून पण एकच वेस्ट वॉटर ट्रीटमेंट फॅसिलिटी आहे. पण आय रिअली डोंट नो what kind of treatment they provide even. As most of the times it is going to the rivers and the lakes.
तिथे ते एरो बिरो वापरतात, दॅट्स अ गुड आयडिया का पुण्यात?
भारतामध्ये युव्ही साठी ते युव्ही फिल्टर म्हणजे बेसिकली पिण्यासाठी वापरतात, राईट? पण वेस्ट वॉटर ट्रीटमेंट आय रिअली हॅव नो आयडिया. आय मीन लोक खूप 1-2 करोडचे खूप मोठमोठे घरं घेतात, पण they themselves don't know where their waste water goes.
पण मग भारतात गेल्यानंतर बॉटल वॉटर प्यावं की नाही?
उकळलेलं पाणी.
उकळलेलं. तेच मी करते. मी बॉटल वॉटर पित नाही. माझ्या डोळ्यासमोर उकळलेलं खूप वेळचं पाणी पिते, तर सगळेजण म्हणतात फार फस करतेस तू. तिकडचे लोक म्हणतात
त्रास होतो ना.
हा, पण मला
I would suggest avoid eating salads. ask for चहा rather than पाणी.
हो या. नाही, कच्च तर तिकडे गेल्यावर कमीच खातो, इव्हन फ्रुट्स पण नाही खात.
पॉटकी कंट्रीमध्ये तिचं काय म्हणजे ड्रेनेज सिस्टम नसते, तिथे सेफ्टी टँक वापरतात.
बरोबर.
तर त्या पाण्याचं कसं होतं, म्हणजे हाऊ दॅट डिस्पोजल ऑफ
काका सेफ्टी टँक म्हणजे तुम्ही जो प्रश्न विचारला ना, तर सेफ्टी म्हणजे जो त्याला तो जो टँक वापरतात दॅट हॅज पार्टिशन्स इन इट. म्हणजे आता सेम थिंग वी यूज दॅट ॲट अवर कॉटेज. It's a septic system basically. So whatever the water or the wastewater from the household, it goes to first of all a tank. So that tank itself has partitions in it. So first partition acts as a kind of a primary treatment. The solids do settle at the bottom. The water goes over to the secondary, and then basically secondary नंतर पूर्ण rest of the area मध्ये छोटे छोटे pipes लावलेले असतात आणि the water just goes out. So basically secondary treatment जी चालू असते, जी प्लांट मध्ये होते, except disinfection, you do almost everything over there. पण ते म्हणून तर if you go की what is the location of the groundwater well irrelative to the location of your septic tank.
Correct.
Okay,
Yeah.
Can I ask one
Ravi,
question?
go ahead.
Can I ask one question?
Yes, go ahead, Ravi.
Hi, hello.
बोला ना.
Yeah. It's a somewhat different type of question. I don't know exactly where this your purification plants of water are located, but along the lake, this Ontario lake, there are also nuclear power stations.
Correct.
And the water that comes out of these power stations has gone through radiation, and obviously it is affected by radiation.
Bro.
What kind of concentration is there, and how does it affect the treatment of the water?
So, fortunately, so far, like आपल्या इथे असं radiation exposure तर झालेलं नाही अजून पाण्याचं.
Right. Yeah,
same thing which has happened in Japan few years back.
Right, exactly. Yeah,
right?
that's where the question is coming. But I just want to get idea in the current situation. What is the situation there? What's the status there?
Kaka, I don't work in the water treatment. I work most in the wastewater side. But I can certainly ask this question to my peers. You know, suppose if there is an accident in Pickering Nuclear and the radiation dumps into, what is the safety mechanism we have? Right?
That's correct.
That's kind of question you have, right?
That's kind of question basically. Yeah. That's where it's leading to actually. Yeah, you're right. Yeah. No, because I come from that background. I'm just curious.
अच्छा.
Because
नाही, मी नक्की विचारून सांगेन काका तुम्हाला.
Zarur. Yeah, thank you.
Okay.
Satish Kulkarni, please go ahead. Another question.
सिटी ऑफ टोरंटोनी कंपोस्ट करण्याकरता आपल्याला बिन्स दिले होते, तसे रेन वॉटर कलेक्ट करायला बिन देते सिटी देते का?
नाही, I don't think they do that anymore. मागे द्यायचे असं मी ऐकलं, पण ओव्हर टाइम दे केम अप विथ द सेकंड प्लान, राईट? लाईक स्पाउट, म्हणजे स्पाउट्स जे ओल्डन सिटीमध्ये सॅनिटरी सुअर मध्ये कनेक्ट करायचो, म्हणजे जे आपण कंबाईंड सुअर म्हणायचो, त्यांना कनेक्ट करण्यासाठी they paid money to all the owners of households who are likely to be connected to the combined sewer system. त्यांनी ते if I'm not mistaken, they were giving credit, Kaka.
Okay, पण no rain water barrel.
नाही.
Okay.
I don't think there are any more questions. Atul, if you do see William Fernandez, say hi from me, because I used to be on lot of waste management project, of course, from finance side. I don't know anything about technical side, but I was really impressed by the team that used to be there, and William was one of them.
That's right.
Do say hi to him.
For sure, I will.
Thank you.
One more last thing. So I found out there are around 2,444 wastewater facilities in Canada.
Oh,
total about 2,500 in the entire country.
Approximately 2,500, yes.
That's pretty good. Okay, so now I will call on Shashi Doglekar to give our wonderful presenter, Atul Marathe, a vote of thanks. Shashi.
नमस्कार. आपल्यापैकी अधिकांश व्यक्तींनी पाण्याचा तुटवडा सोसलेला आहे. मुंबईसारख्या मोठ्या शहरात नळाला पाणी सकाळी 2 तास व संध्याकाळी 2 तास यायचे. पिण्यासाठी लागणारे पाणी पिंपात किंवा माठात भरून ठेवायची पद्धत प्रत्येक घरातून असायची. मानवाच्या शरीरात 60% पाणी असते. आपल्या विभिन्न अवयवात पाण्याचे प्रमाण साधारणपणे असे: त्वचा 64%, मेंदू व हृदय 73%, अस्थि 31% व स्नायू 79%. आपल्या आयुष्यात पाण्याचे मोठे महत्व आहे. कॅनडात आल्यापासून गरम पाणी व थंड पाणी मिळवण्याची सोय आता अंगवळणी पडली आहे. पण पाण्याचा प्रवाह कायम ठेवण्यासाठी किती यंत्रणा लागते व किती सोपस्कार करावे लागतात याचे सविस्तर वर्णन आज श्री अतुल मराठे यांनी मोठ्या शिताफीने आपल्या समोर मांडले. अरे बाप रे, केवढे हे शास्त्र! माझे तर तोंडचे पाणीच पळाले आहे. मराठी मंडळ टोरंटोच्या ज्येष्ठ समूहातर्फे मी श्री अच्युत मराठे यांचे शतशः आभार मानतो. नमस्कार.
Dhanyavad Kaka, thanks for giving me an opportunity to speak. Like no one wants to talk about, as I said, pee and poo or shit, but this is how it is.
Yes.
That's the way it is every day.
It has to be.
Yeah.
Okay.
Thanks, Kaka.
Okay,
Thank
Atul.
Thank
Many thanks.
Many thanks. Yes.
thanks. Bye.
Okay. Okay, I'll close the meeting.